Hello, welcome to this Python tutorial where we're going to make some particles using the turtle module. That's the idea. And by the way, I'm wearing my sun here. I'm not wearing, this is not for fashion. And if you're from the future, you might not know what this is. If you're watching from the future, this is back in the 21st century. It was the males that gave birth, like seahorses. So that's what's going on here. Anyway, this is my little son, Jojo. So he'll be coding along with us. Right, I'm going to program the Python using Trinket, which is a free online place. You know where you do the coding and then it appears on the other side. So you can do Python in the browser. Another place is REPL. So you could do it on REPL if you like that. I'm going to do it on Trinket. You can make a free account, or you can start coding like straight away in here if you like. Anyway, if you've made yourself a free account, you click on your name at the top there, and then go down to New Trinket, and then we're going to use Python at the top, not Python 3 or Pygame or R or any of that. Python we're going to use. If you don't use this version of Python, what I'm doing probably won't work. And then I'm going to make my font a little bit bigger there. There we go. And let's get started. Oh, we need a name for this. So we're going to make turtle particle. Turtles. That's what we'll call them. Turtle particles. Oh no, don't, yeah, change it back to turtles. Thank you. Okay, right, so first thing we're going to do is import the turtle module. Then we can make ourselves a turtle. What should we call him? Like Shelbert. I'll just call him Bert. Bert equals turtle module, and then capital T and brackets. So this function call here will create a new turtle object and we'll store it in this variable Bert. So Bert is our turtle. If we press play or run, nothing will appear yet. And that's because we need to give our turtle a shape. So Bert dot shape, and then we're going to pass in quotes, turtle. You can also have like square shape, circle shape, and yes, there we go, Bert is alive. Right, let's change the color of Bert. We can say Bert.color, American spelling, and then I like using RGB values, and they go from 0 to 255. Let's have a nice green turtle, around 200. So no red, 200 green, and no blue, and that will go green, yes. So, right, there we go. So what we want to do is have lots of little Berts on the screen. So we're going to use an array or a list for that. I think in Python we call them lists. So list slash array. And so we then want to basically create loads of Berts, maybe make them green, and then just get them everywhere on the screen. So we could get Bert somewhere in a different place by saying go to, and then you can put an X and a Y position. So 0, 0 with this turtle module is right in the middle of the screen. So top left would be minus, say, 2, I think it's 200 this way, 200 that way. So it'll be minus 200 on the X-axis. And as you go up, it's plus 200. Let's just test that out. So minus 200 on the X-axis, 200 up on the Y. Press play. And he moves top left corner. Lovely, perfect. So if we went minus 150 and then up 150, he'll stay about there. Lovely. What we can also do before moving Bert, we can also say Bert pen up, and that will mean he won't draw as he goes. Okay. We can also change Bert's speed. If I put 10, that'll be a lot faster. Boom. If I put 0, it means no animation. It will just appear there very quickly like that. Okay, so let's just comment out speed. We'll keep pen up for now. It might be cool if we get some particles moving around, we could put the pen down and then kind of they would trace their paths as they move around our turtle universe. Right, so we want to make a list of turtles. So we'll call them Berts. Will that be confusing? No. Or yes, it doesn't matter. It's made me laugh, so I'll keep it. So Bert equals, and we do empty square brackets. Not these brackets, but square brackets. And that means Python, could I have a list? So I've got my list. And now I want to make a temporary turtle and place it onto this list. And then I can put that in a loop and make as many particles as I want. So let's make a loop first. So for I in range, and now we can say like, how many babies do we want? How many little turtles do we want? You know what? I'll just put 3 to begin with, and we'll use a variable later on. Colon to start the loop, and then look, we've got an indentation there for our loop. So what we want to do is just say, I want a temporary turtle. So I'm just going to copy this code. My temporary turtle will be there, and then basically I can then say but append temporary turtle. So what that's doing is storing whatever this value is, and in this case it's a turtle object. It could be just a number, so I could just like append 10 on there. I could append your mum, she could go on there, so a string. This append function is like push in other languages. It pushes or places a value or an object onto a list or an array. And a list or an array is just a variable that can store lots of objects or values. That's all it is. It's a variable that can store lots of something. Right, so we want to put our temporary turtle on there. But we also want to do, like we did with Bert, we kind of want to change its shape so it looks like a turtle and things. I don't know how to change words automatically, so I'm doing this fairly quickly, a bit of copy and pasting. Right, so our temporary turtle is turtle shaped, then we change its color to 200 green, then we make sure its pen is up so it doesn't draw around, and then we place it on this list called Berts. And usually lists or arrays are pluralized, so it's got an S on the end, to let people know that it's not just a variable, but it's a list or an array. It's got lots of things on it. So let's just press play. We've just got Bert. Oh, we have actually made 3 turtles, probably, but why don't we see them? Why don't we see 3? We only see 1 down here. It's because they're all stacked on top of each other. It'd be really cool if we could, like, by 3D, kind of like zoom in and then have a look at them. What we could do when we make each one, you know what? No, what we'll do actually, under here we'll have another for loop, and we'll get all our turtles to move somewhere. So we'll say for I. Oh, actually, we could say for I in Berts. So what this for loop does is iterate over or loop over all of the turtles that we've got in here, or whatever object you've got on your list or array, and then it places temporarily each object in the I variable, or whatever you call this. It's basically a current turtle. So let's call it turt. So we know we've got a turtle there. So I want each turtle that's returned from the array or list to move forward by 10. So let's see if that works. Press play. So Bert goes up there, and they've all kind of moved by 10. Right, that's not very much. Let's try 100. There we go. Now we can see them all kind of like shuffling around. So what we really need to do is something clever, like we need to like keep a counter or something. Right. How am I going to do it? I don't know. How am I going to do this? Here's a better way. We'll go to some random x and y. So x and y don't exist yet, and Trinket's making them yellow to say, look, these you can't use these. Python doesn't know what they are. So x is going to equal rand int, and you can go anywhere between minus 150 and 150 on the screen. So right over here to over here, or actually, I probably won't be able to see the whole of my screen. I have to kind of like zoom around. Anyway, and then I want to do the same for y. So y will equal between minus 150 down here and 150 at the top. Now, my program doesn't know what randint is because I haven't imported the random module. So I'm going to import random, and I'll still have a problem because I've got to reference what module that function comes from. so the random module. So I just put random dot to use its functions. Just looking behind me because my Chihuahua Dot is eating very noisily, but I haven't fed her anything. So she's eating something. I'll try. To be continued. I'll find out what she's up to. Right, random.int. So this use of a module dot one of its functions is just what we did here. For example, when we wanted a turtle, we write turtle, because that's the module, dot, and this is one of its functions. And this turtle function returns or makes, instantiates a turtle object. Right, so let's play that. So Bert goes up there, and then our Berts go to random positions. Brilliant. So we've basically got some turtle particles kind of working. And what's nice now is we can go from, when we make our turtles, let's just write a function. So make list. Okay, I've just worked out what my Chihuahua is eating. It's eating little Jojo's Moses basket, the place where he likes to play and sleep. Dot, don't eat that, thanks. Thank you. I've talked to you nicely. Please don't do that. We'll see if that works. She's so cute and naughty. But have you? Oh, I'm not in the camera. Have you noticed when naughty and cute kind of combine? Very special, very disarming. Right. So make list of turtles. There we go. Right, and now we can go 32. Bang. Don't have to change any of the code, and we should have 32 turtles being created, pushed to our Berts list, and then down here we go over the list, we iterate over all of our Berts, and pick a random position for each one, and then make that turtle go to that position. Lovely. Right, so let's keep that to 3, so when we're testing it, it won't take up our time. I've noticed I haven't saved this, so save that. When you do that on Trinket, by the way, it always resizes your font. So I'll make that big again so you can see. So you can see it at home and join along. Right, so what I want to do for a particle system really is add some physics. So we've got to have them moving around. So a turtle object in Python here, in this module, it will have, let's just write this down here somewhere. Each turtle, so let's say we've got a turtle, turt, it will have a position. And that, I believe, returns a vector2 object. So a position vector in programming, in coding, is just a list really, or an array that holds 2 values. Its x position and its y position. So it kind of wraps up its position in one kind of object, this vector, this position vector. So what we need is each particle to have a position. So that's already covered. Tick, done that. But we also need its velocity, so its speed and direction. So we've got vel. So we need to make that, and we need acceleration. And these are both going to be 2D vecs as well. So that's going to be a 2D vec, and this is already a 2D vec, or vector. So all these need to be the same thing, so we can just add acceleration to the velocity. So that's like a force that changes your velocity, like the force of acceleration, or gravity. It changes your speed in a certain direction. And then your speed is basically telling your position to change. If your speed is 0, your position has no change. It just stays. That's interesting. This is kind of deep. It's about physics. It's like, what is speed or velocity? It's when position is not constant. I find that quite interesting. I don't know what I'm talking about, but I find it quite interesting, whatever that is. So what do we need to do? We've got our position for free. The turtle object already has that, but we haven't got velocity or an acceleration. So that's quite easy to add. When we create our temporary turtle, we can just add to this class our own fields. So we can say your temporary turtle, its velocity equals, now, do I say turtle dot I haven't done this before. Turtle dot, is it 2D vec? 2 vec? Is it like that? Can I actually put in the, and I'll say no velocity in the x, no, or no value quantity in the x, no quantity in the y. Is that how I do it? And then do I say the same thing for acceleration? I'll call that ac. Right, let's just save that and play. Right, it doesn't look like that. Bad input on line 20. So it doesn't know what 2vec is. Let's have a look at the documentation. So this doesn't look like what I saw before. Where is, there we go, vec2d. So that's what it should be. I'll put a link to this documentation, by the way, in the video description. So two-dimensional vector class, vec2d, x, y. Right, let's try that again. So vec, was it lowercase? I've already forgotten. 2D. That doesn't look right. My kind of memory is saying, no, it doesn't look right. Vec2D. Let's save that. Try again. Oh, I thought it was working. Right. Object has no attribute vec2d. It does. It's right there. Does it tell me how to use it? Now, if this doesn't work, I'm going to have to do it a different way. Our velocity and things. Vec2d. That all looks correct. Temp val equals, right, let's try that again. Save. It's maybe because the version that I'm working with doesn't use this class, or I'm just using it in the wrong way somehow. Anyway, right, we're going to have to do this different way. Let's try. If I use a tuple, I won't be able to change it, will I? So let's just do it this way. So we want the velocity to have velocity x, and then we want a velocity y. So we're just going to have to store them in 4 different variables. That's not nice. And that'll mean moving them around won't be as easy. But maybe another video I'll find the solution that'll be more satisfying. That's the way to look positive about this. Right, we're almost 20 minutes. Wow, okay. So velocity x equals 0. So all of these can be 0. We're going to have no velocity in any direction, no acceleration. And now we want to write a new function, and I can write it, say, down here. So to create a function in Python, write def, like for define, and we'll call this physics. And then this function is going to receive, I'm going to pass in a turtle, so we'll call that turt, just like we did for the loop, actually, iterating over all our turtle objects. And what we're going to then do is we're going to add the acceleration to the velocity. So vel x plus equals, that just means velocity x equals velocity x plus whatever we're going to put now, plus equals the turt's acceleration in the x direction. Lovely. So we're going to then repeat that for the y direction, and then we're going to add the velocity to the positions. So we're going to have to use the function set position or set pos. So it'll be turt.set. I think I can just write set what x and set y. Let's try that. Set x to this turtle's position x plus its current velocity. So the turtle's dot velocity x. There we go. Now what I'm confused about is, do I have a pos x function? Let's have a look. In our documentation, I think at the start, right at the top, we should have a kind of contents. Set x and set y. So I've got those. Move and draw. Set pos x coordinate. Right. That must be it. Return the turtle's x coordinates. That's what I want. So I don't want pos x, I want x core. Okay. Oops. So let's just sorry, I keep doing that. Let's make sure this makes sense. So I've added the acceleration to the velocity, and now I'm trying to add the velocity to the position. So I've set its x position to its current x position plus the velocity. So that's adding velocity to its current position. So I can do that for the y axis as well. So x coordinate, x coordinate. Lovely. So we've basically done all the physics. Then what you usually do for an Euler physics system like we're using here, which is where you just add acceleration to velocity, then velocity to position. So Euler physics system. Big smiles, makes us sound like some kind of mathematician. What you then usually do, each physics update, you then zero out all of the acceleration. So equals 0. And the acceleration on the y direction, u now equals 0. So if we want to change the position of our particle, we just make the acceleration in either x or y positive or negative. And that's like adding a force in a particular direction. And that will get added to the velocity, and that will get, change the position. Right, so what we need is actually an update loop. So let's say running equals true, and then we'll have a while loop while it's running. I can just write it like that, which means the same thing as while running equals true. This is more efficient. While running, then I can say for, we'll call it for every turtle in the BERT list, physics, and then pass in that turtle. So each turtle gets added in. Lovely. And what we could do is, let's just see if that runs. Let's see if there are any bugs. Right, there is a bug. Unsupported operand type for add, instance method, and int on line 35. Let's have a look. So I can't add. Oh, this is a function, isn't it? Let's try that. That should just be the problem. So this function returns the integer, or the the numerical value that we're after. Lovely. So we've created BERT up there, and then we've created our 3 physics particles, our pertles. Then we run this little loop, and it's still running now. It's running over and over and over again, and it's just running this system, this Euler physics system. But we haven't added any forces. So actually what we could do, when we create our BERTs, we could then add a random amount of acceleration, let's say. So we'll say rand int between minus 10 and 10. I don't know how strong a force that will be. And of course, we need to use the random dot module. Now, if you're getting tired of having to write the whole module out, there are 2 things you could do. One thing is you could write import random as R. And now I can just write, well, I have to write R instead of random. There we go. And I won't show you the other way now. So I don't want this video to be too long. Although, let me know in the comments if you quite like a long video like this, where you can kind of watch and code along. But I tend to think like 10-15 minutes is what people prefer, and then make a series of videos, because obviously things take longer, especially if you're like me and you're kind of giving a tutorial and kind of talking, commenting as you go. That's a lot slower, obviously. Right. Okay, so I just lost what I was doing. Right, when I've created my turtles, I'm now adding a random force to begin with. So that won't move them here. So they'll go to their starting position in this loop. Then this function, the physics function, won't run until you actually call it. And we only call it the first time this while loop runs, then it calls it on each turtle as it goes. Right. Okay. Let's see. Let's stop that and run. Let's go. So it's like an 8-bit kind of snooker game, like that. Okay, right. Do you like my sound effects? That's 8-bit snooker sound effects. Right. Let's try playing around with, when we create each turtle, we'll also say its speed is 0. So we're going to take away its animation. Let's see what happens there. Okay, so we get less of a juddery kind of feel. Maybe just make the speed. So what happens? When I make the speed 1, now they've got to move really slowly to their positions. Okay, and so it's like really low resolution, kind of like moving. If we say 100, it's a lot better. That's cool. And you have the animation on. Okay, so that's fine. That'll do for our physics at the moment. Also, actually, after we've coloured each turtle, just a little tip, we can write pen colour. And then if I say black, each turtle will have like an outline. Or the physics one will have a black outline, which is kind of cool. Okay, save and stop there. So we've got our turtles moving around with acceleration and stuff. What we could do, I'm in my Euler physics system here. I could then say it's velocity x minus equals 0.97, something like that. So each time the physics update loop's running, its velocity, each particle's velocity in the x direction is being multiplied by less than 1. So it's basically friction. It's grinding that number down to 0. Yeah. In fact, I could say if your turtle's velocity x is greater than 0, then grind away at that value until it hits 0. And it might be good to say if it's like less than 0.01, something like that, then it equals 0. Right, and we'll do exactly the same for the y velocity. And let's just, okay, I'll leave that at 0.97 and just see if we see some friction happening. Are they kind of slowing down? Cannot confirm. So let's try 5. I've just realized something. Velocity x is part of a vector. So actually, minus a number doesn't mean it's not moving. It just means it's moving the other direction. So I want the absolute value, which means take this value, and if it's negative, make it positive. If it's positive, keep it positive. So minus 5 will mean the same as 5. That's what we want to do. So for this little test, so we just want the amount of movement, whether or not it's positive or negative. If that's greater than 0, So it's always going to be positive if it's a negative number. It'll be changed into a positive number. If that quantity is greater than 0, then grind it to nothing. And I'm going to say 0.5. So every time it goes through this update loop, physics loop, the velocity will be reduced by half. So it's going to be multiplied by 0.5. So let's try that again. Yes, and they stop almost instantaneously. So let's beef that up to 9. You're right, Jojo. Maybe time to end the video. Definitely need to do another one. There they go. That's lovely. That's lovely. So we've now got some friction happening. Right. Let's just, as I'm talking, make. I don't know. Let's make. Okay. 12. 4 times as many. Right. Little Bert. He's non-physics. There they all go. So the more particles you get, the kind of lower resolution of physics we've got in terms of the movements, the less satisfying it looks. But it's working. Let's put circle in there. So what we could do next time, let's put, I don't know, 7 this time, is kind of have a screen wrap happen. So if any particle goes off the screen, it kind of appears over here. It's like a Pac-Man kind of system. What would also be cool is if we click on the screen, could we like make the particles receive a force and like move around, so we could like hit them, stuff like that, with the mouse. Also, if they hit each other, have a bit of collision. So I'll see if I can do that next video. Do leave any ideas in the comments or requests or questions, and I'll try and answer those. So thank you very much for watching. We made some Turtle Python particles. Lovely. Goodbye from Jojo and Dot, who's not eating anything. Yeah. We had a little talk and it worked. Thank you very much for watching. See you next time. Or never.